Hello everyone, Elias5891 here with another KTANE module tutorial. This time we are covering the Algebra module. This is one that I'm very excited to do as a former math teacher, so we're going to jump right into this one. It does require edge work, so we will grab that first and we will see how this one goes. Edge work, we have 2 in 1, lit MSA, lit SND, PS2, an RJ, and a number, Sierra Juliet 7, X-Ray Romeo 5. Alright, so this is the algebra module. How does this one work? Well, you're going to get 3 stages that look like this. For each of the 3 stages, you will have one variable of A, B, or C. Stage 1, you'll have an A. Stage 2, you'll have a B. Stage 3, you'll have a C. Your goal is to solve for those particular variables. You will also have additional variables, X, Y, and Z. Those can be calculated via the manual here, which is where the expert comes in. The idea is just to punch in the solution to A, B, or C depending on your stage. My suggestion for this one is, as the expert, you're going to initially want to get X, Y, and Z. That way when you get the equations, you can just boom, boom, boom. So let's take a look at this and see what we get for the 3 equations, for the 3 variables on this one. X, as you see here, is equal to n, where n is the sum of the digits in the serial number. So we're going to add all of the numbers in the serial number, all the digits, and that's going to give us n. So that would be 7 plus 5 is 12. So x is 12, but we also have these modifiers down here. These 4 modifiers here only apply to x. These will apply to y when we get there. These will apply to z when we get there. So you're only going to look at the 4 immediately below the variable you're trying to get. So we have x is 12, but we need to look at these. Do we have 3 or more battery holders present? We do not. We only have 1. Do we have an RJ45 port present? We do have an RJ45 present. So, according to this, we need to subtract 1. So we're going to knock that down from a 12 to an 11. Is there a lit bob indicator? No. Does the serial number have a vowel? No. So that's going to be our final result for x. X is 11. Let's do the other 2, y and z. Y, I minus p, indicators minus ports. We have 2 indicators, 2 ports. 2 minus 2 is 0. 2 or fewer battery holders present. That is true. We only had 1, so that's a minus 2. So we're going to subtract 2 from that. Is there a serial port present? No. Is there an unlit FRQ? No. Is the sum of the serial number digits prime? When you said 7 and 5 was 12, 12 is not prime, 3 times 4. So that doesn't apply. So we get y is negative 2. Let's look at z. Z is the easiest one to mess up. I'm going to actually write this one out. Z equals m plus t times d. M is the number of modules. In this case, for the tutorial, we only have 1. T is the number of AA batteries you have. D is the number of D batteries you have. Now, if we had 2 batteries in 1 holder, the quickest way to figure that out, 2 minus 1 is 1, so you have 1 pair of AA's, which is 2 AA's. And if you have 2 AA's and only 2 batteries total, leaves you with 0 D's. And then you simplify. Order of operations says you do the multiplication first, and you get Z as 1. And then we'll look at its rules. No battery holders present. False. Parallel port. False. Lit MSA indicator is actually true. So we're going to add 2. And then sum of the serial number digits is divisible by 3. That would be 12 is divisible by 3, so that's true as well. So we're going to add an additional 1. So we get x is 11, y is negative 2, z is 4. That's the prep work as the expert you want to do. Now we're ready to do equations. So let's clear this away. Let's do some math. For the first equation, we have a equals z divided by 10. Well, that's easy enough. Z is 4. 4 divided by 10, 0.4. So as the expert, we're going to tell it to choose a 0.4. B, 7x times y. 7x times y. Now this is how it's written on the module. If you're mathematically inclined at all, multiplication is commutative and associative, which means you can ignore that parentheses, multiply them in whatever order you want. So you really just have 7 times 11 times negative 2. Truthfully, that's the order I'd multiply them. 7 times 11, 77. (77) times 2 is 154. Positive times a negative is always a negative. If you're a little fuzzy on your rules for adding, subtracting, multiplying, dividing, negatives, or decimals for that matter, I would suggest looking over those. I may go over a couple things briefly, but I'm not going to spend too much time on that. So for B, we get negative 154. 154 negative. And now we get one like this. The third one is always the most complex looking. And you want to be very careful how you read this. Now, if you want to read this completely the way it looks, it would be x times y over 2 plus 11 equals 4 plus c all over 2y. Now, looking at it, I can copy that down too bad. This part, if you do x times y over 2, people will probably get it. But the nice thing about multiplication, as I said, it's commutative, and division's a type of multiplication. So this, if they wrote it down instead like this, that's the same thing. You're going to get the same number. So this part you don't have to be quite as careful with. On the other hand, over here, you got to make sure that 4 plus c is all in the numerator, and the 2y is all in the denominator. My suggestion for making sure that happens is when you read this out, I'd go ahead and put parentheses around it, because parentheses are never going to be split across a division. So it's parenthesis 4 plus c, close parenthesis, over 2y. I mean, it's not going to be like over 2y, because you're not going to have half the parentheses over a numerator, over a denominator. Now, it's up to you how you want to read that, but that's my suggestion. Now, we substitute in numbers. X is 11, y is negative 2, y is negative 2. Simplify 11 times negative 2 over 2. Negative 2 over 2 is negative 1. 11 times negative 1 is going to give me negative 11. Two times negative 2 is negative 4. Negative 11 plus positive 11 is 0, which is going to make the rest of this a little more trivial than normal. At this point, you have 4 plus c divided by negative 4 equals 0. You want to get the c by itself, so you need to multiply both sides by a negative 4. That's going to leave you with 0 equals 4 plus c. And then you subtract 4 from each side. Negative 4 equals c. Negative 4. Let's say we mess this up. You get a strike. If you mistype, you can clear it away. You can put the negative sign at the beginning or at the end. All of that's fine. It's a little hard to hear behind the sounds of finishing a module, but it does make some ding, trill-like sounds. That really threw me off the first couple of times because I thought it was part of a sound pack I had on. It's not apparently, so be aware of that. But that's an algebra. Let's sit this sucker down and get another one. Gotta erase my board. There we go. Alright, edge work. Wow, that's a lot of two factors that we don't use. We have 2 and 1, a PS2, a DVI, and our serial number 543 Hotel Tango 6. We're going to try to find X, Y, and Z. And usually when I give out algebra to an expert, I'll say, alright, I've got an algebra, and my first one is, and I'll tell them the first one, A equals Y over 4. That way, they can get Y, X, and Z, and they can go ahead and have the first answer ready for me. But let's solve. X is going to be the sum of the digits in the serial number. Now notice that that number keeps coming up 3 times, the sum of the digits in the serial number. Comes up here, oops, here, here, and here. So let's jot that off to the side. Sum of the digits of the serial 5, 9, 10, 12, 18. Let's just mark that over there. So X is 18. Conditions, 3 or more battery holders, false. RJ port, false. Lit bulb, false. Serial contains a vowel, false. So it's just 18. For Y, indicators minus ports. 0 indicators minus 2 ports is going to give me -2. Special conditions, 2 or fewer battery holders. That's also true. That's another -2. So -2 minus 2 more is -4. Serial port present is false. Unlit FRQ indicator, false. Sum of the serial digits is prime. 18 is 3 times 6. It's not prime, so we have -4. For Z, modules plus AA's times D. We had no D batteries, so it's just going to be modules plus something times 0, so 1. No battery holders, false. Parallel port, false. Lit MSA, false. Sum of the serial digits is divisible by 3. True. 18 is 3 times 6, so we're going to add 1. So we get Z is 2 this time. Here are my variables. So let's do this. A equals Y over 4. That's -4 over 4. That's -1. So -1 will tell the diffuser. A little harder one. Keep in mind, addition subtraction is also commutative and associative, or commutative rather. So we have X plus Y minus Z over 2. That may confuse people. Do you mean Z over 2? Or do you mean Z over 2? Or where's the over 2 part? Again, ambiguities. If you're familiar with it as the diffuser, you can simplify those a little bit. You could say parentheses Z over 2, Z over 2, which is the same thing. You could also say, well, if I divide something by 2, that's half of it. So that's the same as 1/2 Z. Or, since we're doing decimals in the end anyway, 0.5 Z. Lots of different ways you could say that to get across the idea. I personally am a fan of not confusing my experts. They know they're going to get fractions, not decimals, so I'll usually go parentheses Z over 2. And notice I didn't put the X plus Y in parentheses. Order of operations, I'm doing them left to right anyway, so they don't really serve a purpose. So B equals this. And you may have noticed both in this one and the last one, a and b are already by themselves on one side of the equation. That is true for all of the a and b equations. Those two variables will be isolated from the beginning in both of them. So we substitute 18 plus negative 4 minus 2 over 2. It's 18 minus 4 minus 1. 14 minus 1, 13. 13. Here's our last one. A much simpler one than last time, both to express and to solve. We have xy equals z plus parentheses c over 10, or you could say 1/10 c or 0.1 c, up to you. 18 negative 4 equals 2 plus c over 10. 18 times negative 4 is negative 72. We need to get rid of this 2, so we need to subtract 2 from both sides. Negative 74 equals c over 10. Multiply both sides by 10. Negative 740 equals c. Negative 740. One more. And this time, good, you can't see it. This time, let us not share with you. I'll give you the information, and we'll see how you do with it. So, I'm going to erase my board so I can kind of follow along. Edge work-wise, interesting as always with the two-factor, we have a 1 battery and 1 holder, a parallel port, an RCA port, a serial number of 493, Juliet X-ray 8. Your first equation is going to be a equals y minus 2. Go ahead and solve for x, y, and z. Pause the video if you need to, and then unpause, and we will go ahead and go over it verbally. You won't be able to see it, I'm afraid, but we will go over it verbally. Alright, that should be time to have gotten the variables and a. For b, your equation is going to be b equals parentheses z minus y, end parentheses, all divided by 2. Z minus y, in parentheses, all divided by 2. Last one. Having done that one, you'll get, and this is a fun one, 9 times parentheses y over 2 equals c minus, and this is where I'm going to kind of change up the way it looks a little bit, 1/4 xy. Alright, take a moment. Any of these you have not solved on your own yet, Go ahead and do so. Okay, let's turn the screen back on. See how you did. Here's our edge work. 1 over 1 parallel RCA 493JX8. Variables. X was the sum of the digits in our serial number. 4, 9, and 3, and 8 makes 13, 16, 24. Special conditions. 3 or more batteries is false, RJ is false, lit bulb is false, val is false, so X is 24. Y is indicators minus ports, 0 minus 2 is negative 2. But we have 2 or fewer battery holders, so that's an additional minus 2 to make minus 4. No serial, no FRK, no prime, so minus 4 for Y. Z, modules plus T minus D, that'd be 1 plus 0 times 1, which is 1. However, we did have a parallel port to subtract 6, which puts us at negative 5. And the sum of the serial number digits was divisible by 3, which puts it from a negative 5 to a negative 4. So you get 24, negative 4, negative 4 for your 3 variables. Now let's look at the equations. A equals y minus 2, y is negative 4, so negative 4 minus 2, both negative. You add the absolute values to get 6, keep the sign negative. A was negative 6. For B, it was z minus y all over 2. That's negative 4 minus negative 4. I kind of didn't show this step, but negative 4 minus negative 4 is the same thing as negative 4 plus positive 4, and then they just cancel out, which gave you 0 divided by 2, which is 0. And then C was the fun one. You can see I kind of read this one a little differently. It was actually C minus parenthesis xy over 4, close parenthesis. But I wanted to make sure that that was explicit, so I went ahead and said a quarter instead, or 1/4. Substitute in for negative 4, negative 4, and 24. 9 times negative 4 is negative 36, divided by 2 is negative 18. A quarter of 24 is 6. 6 times negative 4 is negative 24. So you have negative 18 equals C minus negative 24. Which actually gives you negative 18 equals C plus 24. Get C by itself, you have to subtract 24 from both sides, and you get negative 42 as your answer. And that, my friends, is how you do algebra. It's not how you do actual algebra. Well, it is kind of how you do actual algebra too. So if you haven't taken an algebra course in a while, this is not a horrible warm-up. A horrible reminder of some of the things you should have known. Anyway, that's it for this one, guys. I think we've kind of covered the basics. We've looked over the rules. Just a matter of reading very carefully if you're the diffuser. For example, let me run through this one. I'll read these out loud the way I would, just to get one more set of examples on how to say these safely. For this one, what do we have? Sorry, doing some quick calculations. So this should be, so you have A equals y minus 2. B equals x plus y minus parentheses z over 2, or x plus y minus half of z, or parentheses x plus y in parentheses minus half of z. Thank you. Just going to give us 2 1/4 or 2 1/2. 1/2 y plus 7 equals 4c plus z. That would be an easy one to say. Not the easiest one to actually calculate, but easy one to say. But yeah, that's algebra, guys. So, that's it for this one. If you have any questions, comments, complaints, concerns, suggestions, leave them in the comment section down below as always. Until next time, guys, watch me fail to blow up a bomb. No. Blowing up a bomb is dangerous, but a suiting end. Alright, guys, that's it. Thank you so much for watching. Until next time, guys, have fun, don't explode.